Hello students, we are studying the online practicals, paper number 12, section physical chemistry, and today we are going to study the experiment number 2. Title of the experiment is Conductometric Titration. Aim of the experiment is to determine the normality and strength of weak acid acetic acid solution using strong base 0.1 normal NaOH solution conductometrically. We have to determine the normality and strength of acetic acid solution by conductometric titration. So the concept of this experiment is the titration can be performed by measuring electrical conductivity, and we can determine the endpoint from this measurement. Electrical conductivity is the capacity of ions in a solution to carry the electric current. Now we will see the theory of this experiment. As we know, the acetic acid is weak acid, and due to its poor dissociation, it gives the low conductance value. When acetic acid is titrated with NaOH, which is a strong base, the conductance increases slowly due to the formation of strong salt, sodium acetate. After complete neutralization of acetic acid, the conductance increases sharply due to free OH ions, which comes due to the further addition of NaOH. Now we'll see the apparatus required for this experiment: conductometer, beaker, magnetic stirrer, burette, and pipette. Chemicals required for this experiment: given acetic acid solution of unknown concentration, 0.1 normal NaOH solution, etc. Now we will see the reaction. Acetic acid plus NaOH solution gives the sodium acetate and water molecules. Procedure of this experiment: first, rinse and fill the burette with 0.1 normal NaOH solution and adjust the zero mark of this solution. Then pipette out 5 ml of given acetic acid solution in 100 ml beaker and add to it 45 ml of distilled water. Then place the magnetic stirrer into the beaker. Dip the conductivity cell or electrode in the solution and connect it to the conductometer. Shake the solution with the magnetic stirrer and note down the observed conductance. If the magnetic stirrer is not available, we can shake the solution by hand. Add 0.5 ml of NaOH solution every time. Stir well and note the conductance. Continue the titration till conductance increases sharply up to the total 10 ml of NaOH added into this solution. Now for this you have to make the observation table as the two columns. In one column volume of NaOH added, and in another column you have to note down the conductance for each volume, like 0 ml, 0.5 ml, 1 ml, 1.5 ml, 2 ml, like this. It is in first column, and in front of that, in second column, you have to write the conductance of every addition of NaOH solution. After complete readings up to 10 ml, then plot a graph conductance against volume of NaOH added. Observations. Solution in burette 0.1 normal NaOH solution. Solution in beaker 5 ml acetic acid solution plus 45 ml distilled water. Plot a graph of volume of NaOH added against observed conductance. The point of intersection of two lines gives end point or the neutralization point. Now you can observe this graph. On x-axis volume of NaOH added and on y-axis conductivity. Initially, as the acetic acid is a weak acid, the conductance value is very low. But after addition of volume of NaOH in solution, the conductance value increases slowly. This is because the fast moving sodium acetate formation takes place. After neutralization point, the conductance value increases sharply due to the fast moving OH ions which is added by NaOH solution. Here we get the neutralization point or end point, that is the volume of NaOH, that is V2, which we used in calculations. Now we will see the calculation part as the acetic acid versus NaOH. N1V1 is equal to N2V2. This is the normality N1 that we have to calculate for acetic acid. Then V1, that is for volume of acetic acid taken for the experiment, it is 5 ml. This is equal to the normality of NaOH is 0.1 into V2 as the volume of NaOH required to neutralize the acetic acid, and this value we get from graph, that is endpoint V2. Now keeping these values, we will have the normality N1 is equal to 0.1 into V2 upon 5. From this we will get the normality, then we can calculate the strength is equal to normality into equivalent weight. Equivalent weight of acetic acid is 60. So put this value and determine the strength in grams per liter. Result: normality of acetic acid solution we have to mention in normal. Then strength of acetic acid solution, whatever the amount, mention it in grams per liter. Then we will see the conclusion of this experiment. We can determine the normality and strength of acetic acid by this conductometric titration accurately. Then we will see the significance of the experiment. We does not require the indicator for these conductometric titration. We can perform this experiment without indicator. And endpoint we can detect graphically, hence it is accurate. And the last significance, as we can perform these conductometric titrations for turbid and colored solutions, and we can analyze it properly. I have attached a video of this practical. You can watch it. Today we will see the procedure for the determination of normality and strength of weak acid, acetic acid by conductometric titration with 0.1 normal NaOH solution. Now you can observe here, this is the conductometer. From this back side of this conductometer, the conductometric cell is attached. This is connected and dipped into the acid solution. Now into this glass beaker there is 5 ml acetic acid solution and 45 ml distilled water. Into this burette there is a alkali solution, that is 0.1 normal NaOH solution. Now we have to take the readings. Initially note down the reading without addition of NaOH and note down the conductance value. Now add to this 0.5 ml NaOH solution. I will add this one. Shake the solution well and note down the reading. In the same way, again add 0.5 solution. Shake the solution and note down the reading. In this way, we have to add 0.5 NaOH to this acid solution, and to every addition we have to note down the conductance value. Such type of readings we have to take up to 10 ml addition of NaOH solution into this acid solution. Thus we have the readings of the conductance, and from that we have to plot the graph. On x-axis there is a volume of NaOH added, and on y-axis there is a conductance value. From this graph we will have the neutralization point, which we have to use for the calculation or determination of normality and strength of acetic acid. Thank you. Thank you very much.